Magandang araw! Sama-sama tayong matuto sa Teacher Sal Learning Resource Channel. A revised K-12 curriculum. Math 3, Quarter 2, Week 3. Our topic is all about measurement and geometry. For day 1, comparing the capacity of containers indirectly and comparing and measuring the capacity of containers using non-standard units. Determine which one has greater capacity by direct comparison. Capacity is the amount of something or measuring material. Example given: water, sand, rice, mungo beans, salt, that a container can hold. Guess which container has greater capacity. Let's write the tally on the board. Container A for container B. Same capacity. Here is the possible strategy. Fill one container to the brim with a measuring material. Example given: water, sand, mungo seeds. Then pour all the contents from this container into the second container. Observe what happens. If the second container is not completely filled, it has a greater capacity than the first container. If the second container is filled to the brim, the two containers have the same capacity. If the second container overflows, it has less capacity than the first container. Since container B is filled to the brim and there is still water in container A, this means that the capacity of container A is greater than that of container B. Our lesson purpose is to compare the capacity of containers indirectly and to compare and measure the capacity of containers using non-standard units. Let's be familiarized with these terms. Capacity, greater, less, same capacity, indirect comparison, measurement, non-standard unit, iteration, holds more or less. The capacity of container A is greater than that of container B by direct comparison. This time, we will compare the capacities of the two containers using indirect comparison. Fill containers A and B to the brim with any measuring material. Containers C and D are of the same size and shape. Containers C and D are identical containers. Pour all the contents from container A into container C. Pour all the contents from container B into container D. In which container is the level of the measuring material higher, A or B? You're right, it is in container A. So, which container has a greater capacity, A or B? It is container A. This confirms our earlier finding that the capacity of container A greater than that of container B. If container A has more capacity than container B, how else can we say this relationship? The capacity of container B is less than container A. The capacity of container A is greater than the capacity of container B. The capacity of container B is less than the capacity of container A. We can also say container A holds more than container B. Container B holds less than container A. First, pour all the contents of container A into C and mark the level where the measuring material reaches, and label it as. Next, empty container C and pour all the contents of container B into it. Mark the level where the measuring material reaches and label it. Compare the two marks on container. The higher the mark, the greater the capacity. The method of using a third container to compare the capacity of two containers is called indirect comparison. Do the same process on these two containers. Here are two containers. We have container G and container H. Look at the pair of containers. Which container do you think has a greater capacity, G or H? Use the cups to compare the capacities of the two containers. How can we determine which container has a greater capacity using the cups? First, we have to fill each container to the brim with water. Then, we will pour the water from each container into the cups. The container that fills more cups has a greater capacity. Estimate how many cups can be filled with water from each container. Estimated number of cups for container G and for container H. Pour the contents of the two containers into the cups. How many cups were filled with water from container G? We filled 8 cups with water from container G. How many cups were filled with water from container H? We filled 6 cups with water from container H. The capacity of container G is 8 cups of water. The capacity of container H is 6 cups of water. Which container then has greater capacity, G or H? Why? Container G contains 8 cups of water, while container H contains only 6 cups of water. Therefore, container G has a greater capacity than container H. We can also reverse the process to determine the capacities of the two containers. Instead of pouring water from the containers into the cups, we can fill the cups with water to the brim first. Then, we will take note of how many cups it takes to fill each container to the brim. When we measure the capacity of each container, we use cups. In this case, a cup is a non-standard unit of measure. Can you name other non-standard units for capacity? Other non-standard units for capacity include spoon, scoop, glass, and mug. If we have only one cup, fill it with water from each container again and again. Count how many times you fill the cup. The container that fills the cup more times has the greater capacity. Now, try to show how this is done. We call this process of using the same cup again and again to measure the capacity of a container iteration. Form small groups. Each group will get the same pair of containers. but you will use a different non-standard unit to measure them. Measure the capacities of your containers using the unit given to your group. Write down your findings in the table. Look at the table on the board. In the first column, we have the non-standard unit: glass, mug, scoop, bottle of medicine. In the second column, capacity of container X. In the third column, capacity of container Y. Based on the results in the table, which container has a greater capacity, X or Y? Y. You're right, container Y has a greater capacity than container X in any kind of non-standard unit used. The number of units needed to fill container Y is larger than that needed for container X. This means that container Y can hold more. Why are the numbers reported for each non-standard unit different? This is because the capacities of each non-standard unit vary. For example, a scoop holds less than a mug, so you need more scoops to fill a container compared to the number of mugs needed. Which among the non-standard units has the greatest capacity? The list, Y. The glass has the greatest capacity because it takes the fewest number to fill the containers. The scoop has the least capacity because it takes the most number to fill the containers. How do we compare the capacities of containers using indirect comparison? One way to compare the capacities of two containers indirectly is as follows. Fill both containers to the rim with the measuring material. Pour the contents of each container into two identical containers. Compare the levels of the measuring material. The higher the level, the greater the capacity. How do we compare the capacities of containers using a non-standard unit of measure? One way to compare the capacities of two containers using a non-standard unit as follows. Fill both containers to the rim with a measuring material. Choose a non-standard unit of measure, say cup. Pour the contents of each container into cups. The container that fills more cups has a greater capacity. How do we compare the capacities of containers using a non-standard unit of measure? Let's have the formative assessment 1. Compare the capacities of the two containers by writing less than, greater than, or the same as in the blanks. Number 1. The capacity of the water bottle is blank. The capacity of the canister. Number 2. The capacity of the bowl is blank. The capacity of the water bottle. Number 3. The capacity of the drinking glass is blank. The capacity of the mug. Here are the correct answers. Less than, greater than, the same as. Write the capacity of each container in the third column of the table. Here are the correct answers. 7 cups, 8 cups, and 6 cups. For day 2, estimating and measuring the capacity of containers using standard units in milliliters with appropriate tools. Look at this container and the measuring material. Find the capacity of the container using the following non-standard units: the coffee cup and the scoop. Here are sample answers. Capacity of the container, 2 coffee cups and 14 scoops. Our lesson purpose is to estimate and measure the capacity of containers using standard units in milliliters with appropriate tools. Let's be familiarized with these terms. Capacity, milliliters, greater, capacity, less capacity, same capacity, graduated cylinder, measuring spoons. In the activity you just did, the capacity of the container was reported as 2 coffee cups and 14 scoops. What do we call the coffee cup and the scoop we use to measure the capacity of the container? We call them non-standard units. As you have observed, the reported capacity of the container varies depending on the non-standard unit used. In this situation, there is a need for units of measure that everybody recognizes and accepts. We call these standard units. Today, we will study a standard unit for capacity, which is milliliters. Standard unit for capacity, milliliter. Symbol is ml. Measuring spoons are used to measure capacity. Each spoon has a measurement in milliliters. Form small groups. Each group will get a set of measuring spoons. Look at them carefully and examine them. What do you observe about the measuring spoons? They have different sizes. Each spoon has a label, which contains a number followed by ml. Each label shows the capacity of the spoon in milliliters. Repeat after me as we read the labels. When I point to a spoon, hold it and read its capacity aloud with me. Let's start with the first one. One ml is read as 1 milliliter. 2 ml is read as 2 milliliters. 5 ml is read as 5 milliliters. 15 ml is read as 15 milliliters. 25 ml is read as 25 milliliters. 50 ml is read as 50 milliliters. You will work in groups. Use the measuring spoons to find out the capacity of the container I will give you. Here are the materials for each group: container, set of measuring spoons, measuring material. Example given: water, sand, mango seeds, marker pen, popsicle stick, manila paper with a table. For table 1, in the first column, measuring spoon 1 ml, 15 ml, and 50 ml. In the second column, number of times used. And in the third column, you write the capacity in milliliters. In table 2, we have 2 ml, 5 ml, 25 ml. In the second column, you write the number of times used. And in the third column, its capacity in milliliters. Before doing the activity, fill the spoon to the brim. Use the popsicle stick to level off the top of the spoon. You may illustrate this. Give your estimate of the container's capacity. We will write down all your answers. For example, the container's capacity is about 100 milliliters. Assuming the capacity of the container is 100 milliliters. For Table 2. Let's have a class discussion. Each group explain your work to the class. After your presentations, look at Table 1. Did both groups get the same capacity? Yes, they did. This is in case they have the same capacity using the 15 ml spoon. The answers differ because the number of spoons needed to fill the container to the brim is not an exact whole number. If it is 6 spoons, the capacity would be 90 ml. And if 7 spoons, the capacity would be 105 ml. If it is 6 and 1/2 spoons, the capacity would be about 98 milliliters, which is closer to the actual capacity of the container, 100 milliliters. Did both groups get the same capacity for Table 2? Yes, they did. What is the capacity? It is 100 ml. Based on the results shown in Tables 1 and 2, what is the capacity of the container? It is 100 milliliters. Why are the numbers in the second column different? This is because we used spoons with different capacities. Which measuring spoon required the least number to fill the container to the brim? Why? It is the 50 milliliters spoon because it has the greatest capacity among the spoons. Which measuring spoon required the most number to fill the container to the brim? Why? It is the 1 milliliter spoon because it has the least capacity among the spoons. What relationship can you see between the number required and the unit of capacity? The larger the unit of capacity used, the fewer units are needed to fill the container to the brim. Conversely, the smaller the unit of capacity used, the more units are needed to fill the container to the brim. A graduated cylinder is a tool used to measure the amount of liquid an object can hold. It comes in various sizes, with typical capacities, ranging from 10 ml or milliliters to 1000 milliliters. Look at this big picture of a 100 milliliters cylinder. Look at this big picture of a 100 milliliter cylinder. See the markings on it. This show how much liquid is inside. We'll write on the picture with a whiteboard marker so we can use it again. Count aloud the number of marks between each 10 milliliter step as I point to them, from 10 to 20, from 20 to 30, and so on. Notice that in some cylinders, there are no marks between 0 and 10. For example, there are 10 marks from 10 to 20, which means that in a 100 milliliters graduated cylinder, each mark represents 1 milliliter. In a 250 milliliters graduated cylinder, each mark represents 2 milliliters. Reading a graduated cylinder. Place the graduated cylinder on a flat surface, such as a table. Observe that the surface of the liquid in the graduated cylinder curves downward at the top. This is called the meniscus. Always position your eyes at the same level as the meniscus when measuring the liquid. Read the measurement at the bottom of the meniscus for accuracy. Look at this container. Its capacity is 80 milliliters. Estimate its capacity in milliliters. Fill the container to the top with water. Pour all the water into the 100 milliliters graduated cylinder. Take turns reading where the meniscus, the curved surface of the water is. It should be at 80 ml. One of you will use a whiteboard marker to draw an arrow showing where the meniscus is. If the meniscus is at the 80 ml mark, what then is the capacity of the container? You're right, the capacity of the container is 80 milliliters. Look at this container. Its capacity is 450 milliliters. Fill it to the top with water. Pour all of the water into the 100 milliliters graduated cylinder. After pouring 100 milliliters into the graduated cylinder, ask yourselves, did we already transfer all the water from the container? No, there is still water in the container. So how can we measure the remaining water in the container? We can pour the first 100 milliliters into a basin or any large container. Then, pour the remaining water into the empty graduated cylinder. There's still water remaining in the container after pouring another 100 ml into the graduated cylinder. What should we do? We can repeatedly fill the 100 milliliters graduated cylinder until all the water from the container has been transferred. How many times did we get 100 milliliters? It was 4 times. How many milliliters is this? It is equivalent to 400 ml because 100 plus 100 plus 100 plus 100 equals 400. Is this the total capacity of the container? No, we need to add the remaining 50 milliliters to 400 milliliters. So what is the capacity of the container? Its capacity is 450 milliliters. Here's an illustration of 4 filled 100 milliliters graduated cylinders and a fifth one containing 50 milliliters water. We were able to fill the 100 ml graduated cylinder 4 times. 100 ml plus 100 ml plus 100 ml plus 100 ml equals 400 ml. Adding the remaining 50 ml, we have 400 ml plus 50 ml equals 450 ml. Therefore, the capacity of the container is 450 ml or milliliters. What standard unit of capacity did we learn today? We learned about milliliters. What is the symbol of milliliters? The symbol of milliliters is ml. What measuring tools can you use to measure the capacity of a container in milliliters? To measure the capacity of a container in milliliters, we can use measuring spoons and graduated cylinders. How can you measure the capacity of a container in milliliters? One strategy is as follows. Pour the contents of the container into the 100 milliliters or ml graduated cylinder. If there is still water in the container, repeatedly fill the 100 ml graduated cylinder until all the water from the container has been transferred. Add to this total the remaining ml if there are any. Choose the closer estimate for the capacity of each container. Here are the correct answers. Determine the capacity of each container. Here are the correct answers. For day 3, estimating and measuring the capacity of containers using standard units in liters with appropriate tools and relating liter and milliliter. Our lesson purpose is to estimate and measure the capacity of containers using standard units in liters with appropriate tools and to relate liter and milliliter. Let's be familiarized with these terms. Capacity, milliliters, liters, greater capacity, less capacity, same capacity, graduated cylinder. To estimate and measure the capacity of containers using standard units in liters with appropriate tools and to relate liter and milliliter. Here is a large container with a capacity of more than 1 liter and a 100 ml graduated cylinder. You will find out the capacity of the container in milliliters. What steps can you take to measure it accurately? Fill the container to the brim with water. Pour the contents of the container into the graduated cylinder. If the amount of water is less than 100 ml, read where the meniscus is. If the amount of water is more than 100 ml, repeatedly pour the water from the container until all the water has been transferred. Take note of how many times you poured the water into the 100 ml graduated cylinder and add the remaining ml to this total. How do you read a graduated cylinder? Place the graduated cylinder on a flat surface such as a table. Observe that the surface of the liquid in the graduated cylinder curves downward at the top. This is called the meniscus. Always position your eyes at the same level as the meniscus when measuring the liquid. Read the measurement at the bottom of the meniscus for accuracy. Estimate the capacity of the container in milliliters. Start pouring the contents of the container into the 100 ml graduated cylinder. If there is still water in the container, repeatedly fill the 100 ml graduated cylinder until all the water from the container has been transferred. The expected answer is 1,500 ml. We can use a larger standard unit to report the capacity of the container. Bigger quantities of liquid are measured in liters. Here's a 1 liter graduated cylinder. The markings on the cylinder highlighting how you indicate the amount of liquid inside. As before, cover it with plastic so you can reuse it. Use a whiteboard marker, pen for any writing on the illustration. Count aloud the number of small marks between each 100 ml step, for example, from 400 ml to 500 ml, from 500 ml to 600 ml, and so on, as I point to them on the graduated cylinder. Each smaller mark on the graduated cylinder equals 10 ml. Example, between the 400 ml and 500 ml marks, there are 10 smaller marks. This indicates that each smaller mark represents 10 ml, since 100 ml divided by 10 marks equals 10 ml per mark. This means that for a 1000 ml graduated cylinder, each smaller mark represents 10 ml. In some cylinders, there may be no marks between 0 and 100 ml. Standard unit for capacity, liter. Symbol is L. 1 liter is equal to 1000 ml. 1 liter is equal to 1000 milliliters. How can we write 1500 using liter? 1500 ml is equal to 1000 ml plus 500 ml. 1500 ml is equal to 1 liter plus 500 ml. Since 1000 ml equals to 1 liter, we can write it as 1 liter. This gives us 1 liter plus 500 ml. Thus, we can also report the capacity of the container as 1 liter and 500 milliliters. Since 500 is 1/2 of 1000, we can write 500 ml as 1/2 L. This gives us 1 liter and 1/2 liter. Therefore, we also can say that the capacity of the container is 1 and 1/2 liters. Capacity of the container. 1500 ml is equal to 1 liter and 500 ml. Is equal to 1 liter and 1/2 liter. Is equal to 1 and 1/2 liter. Here's another container with a capacity of 3 liters and 250 ml. Estimate the capacity of the container in liters and milliliters. Start pouring the contents of the container into the 1 liter 1000 ml graduated cylinder. If there's still water in the container, repeatedly fill the 1 liter 1000 ml graduated cylinder until all the water from the container has been transferred. How many times did we get 1 liter? It was 3 times. How many liters is this? It is 3 liters. So what is the capacity of the container? Its capacity is 3 liters and 250 milliliters. Bring out your show me boards. Write each given capacity in liters or in a combination of liters and milliliters. Some of you will present and explain your answers to the class. Here are the expected answers. What standard unit of capacity did we learn today? We learned about liters. What is the symbol of liters? The symbol for liters is L. How can you measure the capacity of a container in liters? One strategy is as follows. Pour the contents of the container into the 1 liter or 1000 ml graduated cylinder. If there's still water in the container, repeatedly fill the 1 liter 1000 ml graduated cylinder until all the water from the container has been transferred. Add to this total the remaining ml if there are any. How many milliliters are there in 1 liter? There are 1000 milliliters in 1 liter. 1 liter is equal to 1000 milliliters. What tool can we use to measure the capacity of containers in liters? We can use 1 liter graduated cylinder. For your assessment, encircle the letter that gives a better estimate of the capacity of each container. Here are the correct answers. Determine the capacity of each container in liters and milliliters. The capacity of the pail is blank. The capacity of the plastic jug is blank. Here are the correct answers. For day 4, measuring and comparing the capacity of containers using standard units, liters and milliliters, using appropriate tools, and determining the appropriate unit of measure for measuring the capacity of container. To measure and compare the capacity of containers using standard units, liters and milliliters, using appropriate tools, and to determine the appropriate unit of measure for measuring the capacity of containers. Let's be familiarized with these terms. Capacity, milliliters, liters, greater capacity, less capacity, graduated cylinder. This illustration shows 1 ml, 5 ml, 25 ml, and 50 ml measuring spoons. Guess the capacity of each measuring spoon. Here is an illustration of 1 liter graduated cylinder and a 1 ml measuring spoon. Which of the two measuring tools has a greater capacity? It is the 1 liter graduated cylinder. How many 1 ml of water can fill a 1 liter graduated cylinder? It takes 1000 ml. Why? It is because 1000 ml is equal to 1 liter. 1 liter is equal to 1000 ml. Here's a container with a capacity of 2 liters. Estimate the capacity of the container. Your class will be divided into 4 groups. Each group will be given with the following materials: a 50 ml measuring spoon, a 2-liter container, a basin or pail filled with water, and a funnel. Complete the table 1. For the second column, number of times used, and in the third column, its capacity in ml. Fill in the table once you are done. Did all of you get the same capacity of the container? Yes, we did. Possible reasons for the differences in your answers are: the spoon was not filled to the brim before pouring it into the container. Some water spilled while we were pouring it into the container. How many times did you pour water using the 50 ml spoon? We poured the water using the 50 ml spoon 40 times. What is the capacity of the container? Its capacity is 2000 ml. We know that 1000 ml is equal to 1 liter. How can we express 2000 ml in liters? It is equal to 2 liters or 2L. Why? We can express 2000 ml as 1000 ml. Then we replace 1000 ml by 1 liter because 1000 ml is equal to 1 liter. 2000 ml is equal to 1000 ml plus 1000 ml. 2000 ml is equal to 1 liter plus 1 liter. 2000 ml is equal to 2 liters. This time, you will determine the capacity of the container using a 1 liter graduated cylinder. Take your time and complete the task. Table 2, capacity using a 1 liter graduated cylinder. Did all of you get the same capacity of the container? Yes, we did. Possible reasons for the differences. The water was less or more than 1 liter before pouring it into the container. Some water spilled while we were pouring it into the container. How many times did you pour water using the 1 liter graduated cylinder? We poured the water using the 1 liter graduated cylinder twice or 2 times. What is the capacity of the container? Its capacity is 2 liters. Water using the 1 liter graduated cylinder was poured 2 times to get the capacity of the container. Did we get the same answer using both measuring tools? Yes, we did. Which of the 2 measuring tools is easier to use for determining the capacity of the container? It is the 1 liter graduated cylinder. Is a liter a larger standard unit of measure than a milliliter? Yes, it is. So which unit of measure is more appropriate to use for reporting the capacity of large containers? It is the liter. For containers with larger capacities, it is more appropriate to use liters as the standard unit of measurement. Look at this container. Its capacity is 200 ml. Use the 50 ml spoon to find out its capacity. Take your time to finish the task. Table 3, capacity using a 50 ml spoon. Fill in the table once you are done. Did all of you get the same capacity of the container? Yes, we did. Possible reasons for the differences in your answers. The spoon was not filled to the brim before pouring it into the container. Some water spilled while we were pouring it into the container. How many times did you pour water using the 50 ml spoon? We poured the water using the 50 ml spoon 4 times. What is the capacity of the container? Its capacity is 200 ml. Water using the 50 ml spoon was poured 4 times to get the capacity of the container. Now, here's the same container and the graduated cylinder filled with 1 liter of water. I will pour 1 liter of water into the container. Observe what happens. What happened when I poured 1 liter of water into the container? Some water spilled over. So what does this mean? It means that the container has a capacity that is less than 1 liter. In this case, the more appropriate standard unit of measurement to use is the milliliters because the capacity of the container is less than 1 liter. For containers with smaller capacities, it is more appropriate to use milliliters as the standard unit of measurement. Can we use the 1 liter graduated cylinder to determine the capacity of the container? What are your ideas? We need to reverse the process. Instead of directly measuring the object, we can fill the container to the brim with water, then transfer its contents into the graduated cylinder and read the measurement in ml. Watch as I show you the process. Take turns reading where the meniscus, the curved water line is. The correct reading should be 200 ml. How do we determine which unit is more appropriate to use for a given capacity of a container? For containers with smaller capacities, we use milliliters, and for larger capacities, we use liters. What are some examples of containers where milliliters or ml is the appropriate unit for measuring their capacity? In medicine cups, teacups, and teaspoons are containers where milliliters ml is the appropriate unit of measurement. What are some examples of containers where liters or L is the appropriate unit for measuring their capacity? Jugs, buckets, and pails are examples of containers where liters is the appropriate unit of measurement. For your formative assessment, what is the appropriate unit to measure the capacity of each container? Write L for liters and ml for milliliters. Here are the correct answers.